Okay, welcome back everyone. So this is another week of Unity Workshop, and we are doing multiplayer games this week. So this workshop should span across 3 weeks if I could find the content to do so. But I am pretty wishful about it because I haven't planned what I should teach next 2 weeks. But today we're gonna go through some of the basics for multiplayer and how you can set up your project in Unity 6 to make use of the new multiplayer tools thingy that they have to make your development of multiplayer games much easier. So before we start, please scan this QR code for attendance if you haven't already. Okay, and I would also kindly request you all to create a new Universal 2D project if you haven't already. So this will be the project that we'll be using. Please make sure you use one of the Unity 6 versions and then click on connect to Unity Cloud. If you haven't connect now, it's okay, you can connect later anyways. But please make sure you just create a new Universal 2D project for this. So I already have one created, so I don't need to create it now. Cool. So we're going to start with a very simple term like what is multiplayer? What is multiplayer? Multiple players? Yes. Okay. It doesn't take a rocket scientist to figure out this is actually a combination of multiple and player. Essentially, what it means is that you will be able to connect multiple players inside the same game session. And it requires communication between players via the network connection. It's getting more and more popular ever since internet become not a commodity but a necessity by all the people in this world. And people started to realize that once you connect multiple people in the same game, they can socialize and it potentially makes the game more fun in one way or another. So when it comes to implementing multiplayer games, as a programmer, there are three major aspects of challenges that you need to solve. The first one is synchronization. What it meant by synchronization is that every player in the game should be synced up. Any action that happens inside of the game session, they should be reflected across all players' clients. And any action that the player takes, okay, they should also be reflected to the rest of all the players inside of the game session. So imagine if you play any multiplayer game right now and you realize that your friend is constantly 2 seconds behind you in terms of the game session. So, it's not good experience because whatever you say now is going to happen 2 seconds later for your friend. And if you're hanging out in a Discord voice call, they're gonna be like, why are you so ahead, right? So it's difficult to communicate. And there may be also several other issues that arise from this because the game state doesn't sync very quickly. There will be problems. If it doesn't sync properly, then you might encounter bugs. The second problem is latency. So as you know, the fastest the fastest thing in the world is light. You can't go faster than light. And the internet communicates through light and electricity. So there will be some kind of latency. Even if you're just in Earth, there will still be some level of latency. So when it comes to creating multiplayer games, you need to try to minimize latency. You don't want the player's action to happen now on their local device, and then it happens only 3 seconds later on your server, or like it only reflects to their local device 3 seconds later. This causes a very bad gaming experience for practically everyone. So latency is one of the major things you need to solve as well. And there's also security. So when you put something on the web, there's gonna be some kind of things happening. It's not just about protecting your players' private information. For example, there are things like their IP addresses, um, their IP addresses and other stuff on their device, other kind of private information. It also includes things such as keeping your network infrastructure safe from malicious attacks. Things like DDoS attacks. Anyone here heard of DDoS attacks before? Yeah, you go on any website right now, it tells you Cloudflare is providing the DDoS protection kind of thing. So these kinds of attacks can bring down your servers and your players will not be able to play the game if you don't solve these kinds of problems. You also want to prevent cheating. When you have a single player game, it doesn't matter who cheats, right? Technically speaking. But when you connect it to the web where multiple players are connected in the same game session, if there's one cheater, it may cause other players to be frustrated. If there are 10 cheaters, then basically your game is not the game anymore, it's just a cheater galore. Flashbacks to when they made CSGO free, right? All the cheaters are crawling around in the game lobbies. And every single game you queue into, there's at least gonna be somebody wall hacking. There's gonna be another guy aimbotting, and one in every 2 games you'll see some rage hack that's just spinning around and just one-shotting everyone at AWP, I think. Yeah, so these kinds of things would happen, and these are the challenges that you need to solve as a programmer. Now, I won't be going too much into the security side of things because this is too deep into the rabbit hole, and if you are ever interested in making multiplayer games as a career, then in the future you will probably touch on this in the company itself instead of learning it from me, which doesn't have much industry experience anyways. So we're just gonna go through the basics on how you can solve synchronization and how you can just set up a multiplayer game that you can play with your friends, assuming that they don't cheat. So the first thing that we need to know about when it comes to designing a multiplayer game is to figure out what network architecture you want to use. There are 2 main types of network architecture that you can use. The first one is a client-server architecture. So this is the architecture where you have a server hosted somewhere in the world that manages over the entire game state. And whatever your players do, they will communicate to the server and through the server. So all communication by the player is going to go to the server first before it reaches the other game clients in the same session. And it's more commonly used for games with a large online player base or games where you have more people per session. So we're looking at games like League of Legends, Counter-Strike, Overwatch, MMORPGs like Diablo. So all of these, they use client-server architecture. All the game sessions are being hosted on the server, and whatever the player does, it only sends those kinds of commands to the server. And all the logic flow all runs in the server. The second type of architecture is peer-to-peer. This is peer-to-peer. Anyone here heard of peer-to-peer before? Anyone here heard of torrenting before? Yes, that's also a type of peer-to-peer technology. Basically, what peer-to-peer means is that you don't have a central server that disseminates the data to all the clients in your session. So instead, your players will directly communicate with each other to send data across. So it's usually used for smaller games with low player count per session, or games that doesn't make online as big of a thing as they usually are. So I think the largest game that I could think of that does peer-to-peer is GTA Online. That's why cheaters are so common there, because it's peer-to-peer. Minecraft local multiplayer is also done with peer-to-peer. But if you host the server or you use Minecraft Realms, right, that would be client server. Other games like Overcooked also uses peer-to-peer. So you see there's low concurrent player counts. And there's really no need to have a server that disseminates the information. So, to look deeper into what these architectures do, the client server architecture have the server maintaining the game state. This means all of your game's logic code, including physics simulation, will run on the server. And what the client is, it basically just relays input data and then it sends it to the server such that the server can handle its physics and game update ticks and stuff like that. So the pros is that the state will be consistent for all players in the same game session because every input goes to the server first and then the update will only then get distributed to all the players and then gets reflected on their screen. And it's also easier to prevent cheating with some level of server-side anti-cheat and input validation. Since all the logic runs on the server, you can't just arbitrarily modify the memory in the local client to say that my bullet does 10,000 damage. Okay. Instead, what it's going to do is that you say, I fire a bullet in this direction. Then what it does is that it goes to the server and then the server says the bullet is fired in this direction. I run the physics simulation for this bullet. It hits someone. Then the damage is calculated on the server as well. So these kinds of input validation makes it much easier for you to catch cheaters, albeit it's not always going to be correct. It's not always going to be like it's not going to fully prevent cheaters from happening, but it makes it easier for you to implement these kinds of measures. The cons to this is that it requires a dedicated server. And if any one of y'all did web development before, you'll know how expensive it is to rent a server right now. Even though it has gotten cheaper over the years, but it's still quite expensive. And this may or may not be the solution that you're looking for, especially when you're starting off doing multiplayer. There's also a higher local latency because here we need to introduce a concept called the round-trip latency. What a round-trip latency means is that the time taken for a network request to go from the local to the server and back. So this is one round trip. The request goes from the local device from the client to the server, and then it comes back. Usually this latency is calculated in milliseconds because light is pretty fast. So if you play any kind of online games right now, you see that it tells you the latency is 7 milliseconds. But actually that 7 milliseconds is not round trip, it's half a round trip. What it means is that 7 milliseconds is the time taken for your command to go from your client to the server. So it takes 7 milliseconds to go to the server, but actually whatever that happens locally on your device is only going to be reflected 7 milliseconds later after the game logic has been updated on the server. This is why the latency of one round trip is 14 milliseconds as opposed to 7. And so if you have a very high latency, you'll realize that in these kinds of games, you kind of just lag behind. What it feels like is that you move forward for a couple of steps, and then the request comes back from the server saying that you're not supposed to be in this position. You're supposed to be behind. Then you get teleported behind the game. These kinds of lags, anyone experienced it before, maybe like 15 years ago when internet is still a new thing. Yeah, these kinds of things happen pretty often. And this is caused by the round trip. So games try to sort of work around this by making sure that by having this workaround where whatever that you input in the local client server, in the local client, it sort of simulates it locally first. So it makes it feel like your input has no latency. you actually already moved forward. You can see in the game you moved forward. But in the server, you are actually lagging behind by 7 milliseconds. And when the packet comes back, so when the update reflected back, like, oh, 7 milliseconds ago, I'm in this position, but now I'm here. If the difference is not big enough, it's not going to correct you. So it lets you stay there. But if the difference is bigger than some kind of margin of error, it forcefully drags you back to the location that is sent by the server. And this is how the lag happens. When you have a high enough latency and the local simulation doesn't match what the server gives, the server has the higher authority, so it corrects your current movement and it brings you back. So far, are we having any problems? Any questions? No? Good. So the second type of architecture is peer-to-peer. I think this has sort of gone much. It's not as popular nowadays anymore because you don't play a lot of games that use peer-to-peer technology anymore. A lot of game companies they much prefer having a dedicated server because it's easier for them to implement server-side anti-cheat, and it's also easier for them to collect player information. Things like authentication and save data, and so you don't store those kinds of things locally anymore. They have sort of like a centralized account system to do that for you. So, but for indie games, this is still the way to go because it's pretty easy to set up. And we'll also be going through peer-to-peer in for this workshop because it's dirt easy to set up. It's the easiest way to set up any multiplayer game. So in peer-to-peer architecture, players communicate directly with each other. So say if I am currently in the game session with one of y'all, whenever I do a new update, I tell everyone in this session that I moved forward by 1 step. Then everyone in this session will be like, I move forward, Juan moved forward by 1 step. So in my game client, I show that he moved forward by 1 step. So instead of having to go to the server and the server validates this information and then sends it to everyone, there is no sort of input validation that happens. Whatever that is sent by the client, we trust it as a source of truth and then we just follow whatever it says. The good thing about this is that it has much lower latency because local updates can be shown immediately. And since other clients trust it as the single source of truth, I don't need to have any kind of correction and I don't have any risk of lagging behind in that particular sense. There's less of a reliance on infrastructure because I don't really need a server to do peer-to-peer connection. There are some limitations because with peer-to-peer you are sort of exposing the other player's IP address in the same session, and in more ways than another it might cause a security risk to the players in the session. So nowadays, even though games are set to be peer-to-peer, there are some level of IP masking through the use of a relay server, which basically relays your data to an edge server somewhere in the computing infrastructure, somewhere in the networking infrastructure, before it gets sent to the other player in the same session. But nonetheless, it is still faster than having a dedicated server somewhere because this relay server can be all across the world instead of being in one centralized location or several distributed locations. It's also easier to cheat because, as you could have already imagined, since other clients take whatever I send as the single source of truth, if I were to cheat, I just need to modify things in the memory such that whenever I press W, I move forward 10 steps at once. Then you guys will trust that 10 steps at once is how much I moved, and it just shows up there. So these are the ways how you can cheat in a peer-to-peer peer-to-peer architecture games, but don't tell others that I said this. Okay. And you might have synchronization problems because You know, every player in the session might have a different latency connecting to other clients in the session. So if I'm in Singapore and you're in North America and then the other player is in Europe, okay, it's like we're in three parts in the world that doesn't really meet each other. The synchronization gets wanky because what I send to the NA guy is probably going to be longer. It takes longer to get to the North America guy than it takes to go to the Europe guy. Then the Europe guy will see my actions first before the North America guy would. And there will be some synchronization issues in this regards. And when it comes to peer-to-peer architecture, you can also have these kinds of host setup, which is sort of like a pseudo server. What it does is that it handles server authoritative updates. In certain cases, you want certain logics to only run on the server. For example, if you play a game of Pong, okay, you play a game of Pong. Anyone here never played a game of Pong before? Okay, if you play a game of Pong, you know we have two platforms, which is the player, right? And then there's the ball. So if the ball is updated per client, it's going to look very off. And sometimes, you know, if one side cheat and one side don't, then how are we supposed to calculate all these kinds of things, right? So usually, generally speaking, the ball should be updated by one authority only. And this authority is the host in this peer-to-peer session. So what it does is that this ball will only be updated by the host, it moves by the host, and all other clients only listen into this host to figure out where this ball is currently. Okay? Yeah, so we have the host pseudo server available for peer-to-peer architecture. In fact, in most peer-to-peer games nowadays, we have this level of host-client relationship instead of being like fully peer-to-peer. In a fully peer-to-peer scenario, you have all the logics ran separately on all the client devices, and it kind of becomes chaos. So generally speaking, in peer-to-peer games nowadays, you will have one host to keep track of certain server authoritative calculations or updates. So then we also go into server architectures. This happens for both server client and host client setup, which is peer-to-peer. Essentially, there are two types of different server architectures. You can have an authoritative server, which does all the logic and validate player actions. So this is what competitive games do. You have the server control everything so that it makes it easier for you to catch cheats. Okay, and what the client does is it only sends input and receive data. It doesn't do any kind of logical calculation locally. And it's more commonly used in competitive games, like I mentioned. So League of Legends, Counter-Strike, they use this authoritative server setup for their games. Then we also have the non-authoritative server, where the client processes the game logic and tells the server what happens. Then the server relays the updates to other clients. So this is more commonly used in casual and in co-op games, where it doesn't really matter too much to have a fair environment, that the server must do all the logic. And as you can see here, the authoritative server setup requires more computation on the server side because the server must handle all the update logic. Whereas the non-authoritative server acts sort of like half a relay. It might run some server code to do some level of input validation, but it never simulates all the game logic and the game physics. So it's much more computationally light, and it's more preferred for games that doesn't have too much budget. So one such game I could think of using non-authoritative server is Genshin Impact. Okay, anyone here never heard of Genshin Impact before? Cannot be, right? So whatever the server does, it only gets information from the player. The player tells it that I have collected this resource, I've defeated this monster, but uh, but the server never does any kind of physics update. It never does any kind of game logic updates. So it only receives the information and stores it in their account database. And all the physics, all the game updates, they are done locally. Usually they're done locally. There are probably some logics done on the server, but probably not to the extent where League of Legends and Counter-Strike does. They're a competitive, authoritative server approach. In some cases, you would probably want to opt in for a hybrid approach where certain things are authoritative and certain things are non-authoritative, but that's going too deep into the rabbit hole, so I won't cover that. So let's make Pong. Okay, so this demo we're gonna make Pong, and it's going to be difficult to drag Pong over 3 sessions, so probably each session is gonna be only 1 hour long. But I think that would suffice. So, in this workshop, in this new project that you have set up today, anyone here still has troubles getting a Universal 2D project set up? Okay, no, good. So in this Universal 2D setup, we're gonna start by adding the packages required to run multiplayer. So we're gonna use the Unity packages instead of installing third-party ones because it has better integration with the rest of the engine ecosystem. So in the package manager, you want to go search Unity registry for a netcode and install the netcode for game objects. Okay, it's gonna take a while. Okay, you install the netcode for game objects, which is basically all you need to start programming in multiplayer. But it doesn't give you the whole developer ecosystem that you need. Okay, it's taking a while. Why is it taking so long? So once you have netcode for game objects installed, we're also going to install some of the multiplayer things that that Unity provides us with. So we're just going to install multiplayer play mode for now. Okay, we're just gonna install multiplayer play mode. This makes it possible for you to run 2 game clients within the same Unity editor project. So up to 4 actually, up to 4 game clients with the same Unity project. So it makes it easier for you to look at synchronization and see if your multiplayer code is running locally without needing someone else to test it with you. Okay. And finally, we are also going to install the multiplayer tools package, which gives you some visualization tool for multiplayer. Most of the time, it's just for quality of life, and you don't really need it. Yeah, you don't really need this, but you know, this is good. So again, install 3 packages. That's the netcode for game objects, multiplayer play mode, and multiplayer tools. Okay, so now that we have all our multiplayer stuff set up, you start seeing this. So generally speaking, when it comes to creating multiplayer games in Unity, you sort of start with the peer-to-peer setup. Okay, you sort of start with the peer-to-peer setup. And if you really need to make a server out of it, then you can do so as well. You can do authoritative and non-authoritative server with directly inside the Unity editor. But for now, we're just gonna keep things simple. We're just gonna do peer-to-peer. So in this network visualization tab gizmos that you get, it'll tell you the server and the host of which game object that shows up here. And it's also going to tell you how many clients are connected to this game session. Obviously, right now we don't have anything, so we're just going to collapse it. Okay. Let's collapse it and put it somewhere. Okay. So, we're going to get started with the base things that we need. So what do we need for Pong? What do we need for Pong? The player? Okay, what is the player? Okay, it's just bricks. Okay, yes, we just need the player. We're just 2 bricks. What else do we need for Pong? Okay, 1 ball, yes. That is all you need for Pong. Okay, let's not think about all the scoring mechanisms, how to restart everything. We just start with this very simple thing, which is 2 platforms, 1 ball. So we're gonna start with making the platform, which is just going to be, you know, square sprites. Let's call this player. Okay. So let's change the scale a bit. Okay, maybe we do a 0.52 looks good, I think. 0.52 looks good. So that's the player. And we also need to handle different things for this player. Let's start with putting the movement on this player. So we're just gonna create the scripts folder here. Oh, sorry, the scripts folder. And then let's create the script, a model behavior script. Let's call this player movement. So we're not gonna go fancy with the new Unity input system package. We're just gonna do this as primitive as it gets. Okay, we're just gonna do this as primitive as this gets. Okay, so without thinking of how we do this in multiplayer, we're gonna try to do this locally first. So, you know, sorry. So we're just gonna try to do this locally first. And in Pong, basically you press W to go up and you press S to go down. Okay, as simple as that. So we're just going to fuck. That is weird. Okay, so we're just gonna check that. So if input.getKey down keycode.w, okay, we move up. If input.getKey down keycode.s, we move down. So we're gonna store this in a vector2 m position. No, we don't need this vector2. Let's just do a serialized field. Private float move speed. Okay. So as I press W, I'm just going to do transform.position equals equals new. No. Yeah, okay, sorry, it's a read-only set. So transform to position equals new trans equals new vector 3. Okay, it's 2D, so then we just move transform dot position dot x, and then transform dot position dot y plus move speed. Okay, so then since we're doing this in sort of like the you know what? Yeah, okay, since we're doing this in sort of like the thing, so we also need to do at time dot delta time. Then we just does the same thing here, but as we go down, so we minus here. Okay, as simple as that. We did the movement. Let's make sure that this works. So let's attach this to the player. Set this move speed to 1. Let's play. And technically speaking, this should work. Okay, sorry, it should be get key, not get key down. I haven't used the old input system for a long time. So now we should move up, move down. Looks good, looks good. Yes, it moves up and moves down. So now let's try to make this multiplayer. Let's try to make this multiplayer. So it is as simple as changing this as a network behavior. Okay, now this is multiplayer. So now as you get back here, you need to remove this and you attach this again. And it's going to add this thing called the network object onto your game object. So a network object, as its name implies, is an object that exists on the network. So it is also a game object, but now this object will get synced. It will get synced to other clients on this same session. So let's try to add move speed to this. Okay, let's try to add move speed to this. Again, let's change this to 1. Okay, let's change this to 2 because it's faster. So as I hit play here, what you're going to see is that now this works up and down. Okay, this goes up and down as well. And now if I turn this up, okay, there's no client connected yet, so it doesn't show up properly. So yeah, so now we have made our player network. Let's try to add a new player to this. So let's just call this player 1, and then this is player 2. And then let's move player 1 to the left. Let's move it to a -7, I think. And then let's move player 2 to 7. Okay, so now we have these two players in the game. What you're going to notice is that as I press play, both of these move together. And this is not what I want to happen, correct? Because technically speaking, I should only be able to control the pedal, my own pedal, okay? My own player. I'm not supposed to be able to control the other player. So yeah, that is bad. So what I'm going to do here is we're going to add a check. Okay, we're gonna add a check. So we're gonna say if so here we're going to do a public void override void on network spawn. What this is going to do is to initialize this on network spawn. We don't usually use start and awake anymore for network behavior. We use on network spawn. So as it spawns on the network, I can run logic here. So you just keep based on network spawn, and then I'm gonna do if not is owner, okay, this dot enabled equals false. Okay, so if I'm not the owner of this object, then I don't want to be able to move it. If I'm not the owner of this object, I don't want to. Okay, so, but there is still like no owners, okay, because the game still runs on just this one client. So let's try to introduce a new client. We can do this by going into here. Okay, we can do that by first adding a network manager onto our scene. So you want to click on all prefab and then search for network. Wait, sorry. There should be a network manager that's attached. What's this? Oh, that's the network prefab. E. Okay, I think, yeah, you need to create an empty object. Let's call this the network manager. And then we're gonna attach the network manager script onto this. So by doing this, I make this game session network. It has a network manager. This network manager is going to handle all the packages that go and the communication between different servers and try to sync things up properly. So here, the transport, you just select Unity Transport, and the rest of this you don't need to touch yet. Okay, the rest of this you don't need to touch yet. And yeah, that is all that you need to do. No. Okay, then you need to make the player. Okay, you need to make the player a prefab. You need to make the player a prefab. So now I'm just going to remove the player from the scene. Okay, I don't need the player from the scene anymore. What I'm going to do is that in this network manager, you'll see that I have this default player prefab here, where I just drag this in, and this just moves out. Okay, this just moves out. Yeah, correct. Okay, so this just moves out, and now as I press play, what is going to happen is nothing is gonna happen until I pressed on start host. So as I press on start host, you see that now my player is green because now I'm in a network session, and then the client and the host, which is 0, is the owner of this player. Okay, is the owner of this player. Good. Okay, good. So let's set the player back to a transform of 0. Then we can spawn in the middle. Okay. Good. Are we following? Yes. Yes. Are we following? So we also need like Utility for this. You also need like a utility for this. Okay. You just add the script and search network manager. It should be part of the thing. Yeah. No, just play empty. Oh, that's it. Yes. Oh, you delete everything except the network manager. Give me a moment. There should be a spawn point in here, but where is it again? Ah, okay. Yes, where is it? No. As long as you change the thing to Unity Transport, it should automatically add all the components for you. Yeah. In the network manager, there should be a transport where you can change. And we put the player default thing. Oh, thank you. You're welcome. Uh, okay, so what you're going to notice, okay, now let's try to connect it with a second client. We're just gonna go to here window. You should see the multiplayer thing pop up, and then you can click on multiplayer play mode. Now let's click on player 2. Okay, as you tick on player 2, it's going to generate a new play instance, a new editor instance where this player can be ran out. Okay, so as I press play now, okay, as I press play now, you see there is no way for me to join as a client here. So here in Network Manager, you want to add a new script here called, usually I'm just gonna call this the a new script. Where's the script? Scripting, model behavior script. I'm just gonna call this the network manager helper. Okay, this can stay as a mono behavior. And we're just going to have the onGUI method, which I don't remember what you write in here anymore, because who remembers what to draw in onGUI? It's all good. Let me try to get in one of my previous examples. Project count. There should be the helper script here that I can copy. Yes. Correct. Okay. So I just do this, paste. So this is a code that you want to write. It's the network manager reference. I get the component and I do a onGUI which starts these buttons. Okay. So basically what this does is it's going to create 3 buttons on your play screen once you click on play that you can click on to toggle the different options here in network manager. Okay. Yeah, I'll give you guys a short while to copy this. Okay, are we good? Are we good? Okay. While you guys are copying the code, let me just show you what this does. So now as I press play, you're going to see that okay, sorry, I forgot to attach the script. So now as I attach the script to my network manager and I press play, you're going to see 3 buttons show up on the top left corner, which is host, client, and server. So now I'm going to click on host, and it's going to spawn 1 cube for me, and you can see that it spawns 1 player clone in the hierarchy, which is correct. Now here, if I click on client, you see that it spawns the second one for me. Okay, it spawns the second one for me. So now I have 2 players. And as I move, the second one doesn't move. But, oh no! If I go to my client now, you see that nothing is moving. Okay, you see that nothing is moving, even though it's supposed to move. And again, this is not in the correct spawn point that we want the players to be in. There should be one player on the left and one player on the right, correct? So something is wrong here. What is wrong here? Okay, there's something wrong here. So what you want to do is first, let's try to fix this synchronization problem. The position is not synchronized across the client. Right. So the position is not synchronized across the client. So the fix is pretty simple. We go back to our player prefab and we attach the network transform. We attach the network transform component to this. And it asks you what axis to synchronize. Basically, this handles all the synchronization for transform components in Unity. Basically, if it moves on the client, it moves on the host as well, and moves across all the clients in the same session as well. So it solves the synchronization problem for you. And there are several options that we can tick here. The first one, we're going to change the authority mode to owner, because, again, the player movement should be immediately reflected on the player's side. So it gives them the illusion that there's no movement. So we change it to owner. We change the authority mode to owner, such that we can imitate this thing. Okay. Then we're also going to make sure that interpolate is ticked. What interpolate does is that when it comes to actually sending the network data, it doesn't always send it. It doesn't really send it like in every frame per se. I mean, it does send it every frame, but because of potentially packet losses and stuff like that, sometimes when you send the data, it's going to be very far apart. It's not. It's discrete. Okay, you don't send a continuous data as you see on the screen. It's usually discrete. When you receive on the other client side, it's usually discrete. So when you pick interpolate, it's going to interpolate between these discrete data to give you a smoother movement plot, which generally gives the players a better player experience because it looks like everything is smooth and moving. Okay, this is why we usually interpolate things. You can also extrapolate, but extrapolate is not part of the Unity code for game objects package. Sorry, I got a call. Decline the call. So yeah, because of that, it is not here. Okay, but it's okay. So that is just it. That's all you need to do on the network transform. So as I press play, okay, and I start this as a host and I start this as a client, what you're going to see is that now the movement is synced properly. Okay, this is exactly what we're looking for. This is exactly the kind of effect that we're looking for. Correct? This is the effect that we're looking for. But how about the player spawn point? We haven't solved that yet. Okay, we haven't solved the spawn point issue. So when it comes to actually spawning the player in their correct position, we also need an additional script to handle this. So let me create a new empty object, and we're just gonna call this the spawn manager. Okay. And then in my script, I'm just going to add this new folder, In this script folder, I'm just going to add a new script called the player spawn manager. So this can stay as a modal behavior as well, because there is no reason to sync this data across the network. When you have it as a network object, the data will be synced. Most of the data will be synced, but we only need this locally because it only handles the spawn position. So we're going to do this. We're going to have a serialized field of vector 3 array, which is the spawn points. Okay, vector 3 array, which is the spawn points. Okay, so okay, we have the vector 3 array for the spawn points. We assign the spawn points. So there should only be 2 spawn points, one for player 1 and one for player 2. Okay, in this case, one for client 0 and one for client 1. Okay, so we're going to, in start, we're going to initialize this. Okay, we're just going to do this move player. How do I do this again? Okay, we have a private void move player position, I think. Spawn player position. And it takes in a ulong, which is the client ID. So here in the start, I'm going to get the network manager instance singleton instance singleton this should be the on client connected callback. No, on, what's that called? Yeah, it should be on client connected callback. No, I am not gonna put this to you. Instead, I'm going to put this for spawn player position. So I subscribe the thing to the spawn player position so that I can do stuff. Okay, so far so good. So instead of actually letting the what's that called? Instead of actually letting the the network manager handle the spawning, of the outside, so that we can put it on the custom spawn. So here, okay, here, I'm also going to have a serialized field of a game object, which is the player prefab. So this client ID that gets sent over is just going to be 0 or 1. So we're just going to sort of instantiate it as 0 or 1. So we're going to say mPlayer prefab dot no, instantiate mPlayer prefab at the spawn point of the client ID at quaternion.identity, and then let's give this a name. Okay, let's give this a name, and then I'm also going to do a spawn. Oh, that's the problem. Let me think about this for a while. Can I spawn it? Dot, singleton dot spawn. I can't spawn it. Okay. This must be a network object. Network behavior. Because we need to have a network manager on this. Okay, how do I spawn? Instantiate and spawn, yes. Should be a network prefab. Okay, then I don't actually need this to be this, right? This can be a model behavior. Singleton.spawn manager.instantiate and spawn. Yes, correct. Okay, so sorry, this can be a this can be a mono behavior. Okay, so I'm going to pass in the player prefab here, the client ID here, destroy with scene false. Is player object true? False override false. The position, which is going to be spawn points client ID, and then the default quaternion rotation. Shit, this should be a network object. I'm sorry. So essentially now what we do is now we have the thing spawn in the, supposedly it should spawn in the correct position. I don't know, I don't usually do this, but yes, I believe this should work. So let's get back here, and in spawn manager we're gonna attach the player spawn manager here, and then in spawn points it's gonna add this. Player 1 should be on the left, -7, and then that one on 7. Attach the player prefab here. And in Network Manager, we're also going to remove the player prefab, so it doesn't spawn anything anymore. So technically speaking, this is going to spawn it properly. So let's click on play. I don't know, I've never tested this code yet. I'm writing this on the spot as you guys as well. So I click on host. Oh, yes, it spawned, okay. Then I click on client. Oh, yes, this spawns. Okay, now it tells you that only the server has the authority to instantiate and spawn. This is because only the server has the authority to instantiate and spawn. So how do we fix this, right? Is here we just add a fast return dot is server. So if I am not the server, I just return. So I don't call instantiate and spawn if I'm not the server. This is kind of cheesy, but usually you probably wouldn't want to do it this way. But yes, okay, this works. This serves our purpose well, so we're just gonna keep this as it. And we're gonna test the code again, and you're going to see that. Okay, we're going to see that this should work properly as well. Okay, this works, and then on my second, click on client, and this works. I have both players in Pong. They're independent of each other. They sync, as you can see here, they sync. Okay, so it works well. Now what else do we need? The ball, yes, we need the ball. Okay, so we need the ball, we need the ball. Okay, we need the ball. So now let's take a step back. What should the ball be? Okay, the ball should be a ball. Okay, yes, it should be a circle. So should the ball be server authoritative or client authoritative? What do you guys think? Okay, why server? Okay, as client authoritative, you should synchronize it. So that is not quite the reason why. Cliff, why is it server? Not quite. So the reason why we want it to be server authoritative is so that the state is the same for all the clients, even though there's only 2 clients. So what we need to figure out when you have to figure out like what should be client and what should be server, it depends on what this resource is. If the resource is shared across all the clients, So in this case, the ball, there's only one ball and it's shared across all the clients inside of this user. This should be server authoritative because the logic should only run once, and then it should properly propagate itself onto all the clients. When it comes to client authoritative, it's more selfish. Okay, this should be something that only it's not a shared resource. It's something that only the client owns. Then I make it client authoritative. In this case, the client owns the player. All right, the client controls the player, so it should have full control over the player, and that's why the player is client authoritative. Okay, the player pedals are client authoritative. So the ball should be server authoritative. So let's write the code for it. So we're also going to create a new circle for the thing. We're just going to call this the ball. Okay, let's put this into 0. Okay, so very simply, we're just going to create a new script called the ball. Okay, I'm just going to call it ball. Should be no problem. Open this up. And since we want to sync the ball across the network, because every client in this session should see the ball, okay? If you don't see the ball, how are you supposed to play Pong, right? So we're just going to change this to network behavior again. Okay, we change this to network behavior. So now, again, we're going to remove start because we usually don't use start for network objects. We're going to have a public override void on network spawn, which does based on network spawn. So again, because this is supposed, the whole logic should be ran on the server only. So if this ball is currently not on the server, I want to disable its component so it doesn't update itself. So we're just going to do network if network manager dot is server. Okay, if I'm not the server, this dot enabled equals false. Okay, and the rest of it is just like how you would write a mono behavior script for a ball in a local Pong game. We're going to need a we're going to need a serialized field. Where is my on Unity engine? We're going to have a serialized field, a private float, and move speed. Okay, we're gonna have a move speed here, and yeah, okay, I think this should work. It should work. Then maybe we have a rigid body 2D. Okay, maybe we have a rigid body 2D. So on network spawn, and we can still have start. You usually still use start if you need to gain access to motor behavior references. So again, and rigid body is get component. We still get the component. On network spawn, we set this to be disabled if I'm not on the server. So update. So what this does in update, we're going to need a direction where the ball is going right now, right? Sort of. Do we? Do we? Do I need a direction? Okay, technically I don't because the rigid body already has the direction. So I need to launch the ball somehow. I need to launch the ball. So let's give this ball like a private float M launch countdown. So we're just gonna launch this once. I'm just gonna test out the code. We don't actually want to make like a full Pong game yet because I need to stretch this workshop for 3 sessions. So So on network spawn, if I am not the server, I set this to be disabled. If I am on the server, I'm going to start a coroutine. Okay, we're going to start a coroutine here to run the countdown, launch countdown coroutine. Okay, which is just going to be you return new, wait 4 seconds and launch countdown, and then it launches in like launch ball in a random direction. So here I'm just gonna start the coroutine for the launch countdown coroutine. Cannot convert from method group to string. Yes. Okay, sorry. Okay, so I do the launch countdown coroutine here, and I need a launch ball, so I'm just gonna launch this ball. Okay, so we're gonna launch this ball in a random direction. Let's just make it so that it only ever launches to the direction of the player 0. So it only launches to the left side of the map. Okay. It always starts launching on the left side of the map first. Let's go with this logic. So we're going to need a random X direction, a random Y direction. What we're going to do is, we're just going to have a float randx direction. It's going to be random.random range. Okay, the direction should be somewhere between. How do I do the math here? Anyone here do the math? So it should be somewhere between 180, 225 degrees, and 135 degrees. So it should be somewhere between 135 to 225 degree. Okay, I think my math is correct. No. Wait. Wait, I think my math is not correct. Wait, it is correct. It is correct. So this should be the angle. Then I need to get the x and y component from this angle. So float x equals cosine and the y is sine. Yes. And then let me set the rigid body velocity. Which is set to this times the move speed. So because cos and sine always gives me a value between 1. Okay, we'll test it out. If it's correct, it should be correct. Okay, so it should launch it in one of the directions on the x and the y. We don't need to update here. So let's just check to see if this works properly. So we're gonna go into the ball. And we're going to add the ball to this. We're also gonna add the network transform to this. And it should be server authoritative. Let's give this a move speed. Let's give this a move speed of, I don't know, like 2. Again, launch countdown. Let's give this a 3 seconds countdown. So this will launch itself 3 seconds after the first client has been connected. technically speaking, this is not good because we probably want to wait for both clients to connect before we launch. But you know, this is okay. Okay, it is okay to be scuffed for now. Okay, so here, I am going to also add the rigid body. Yes. And now it tells you that, it contains a rigid body, but no network rigid body 2D. You don't need to heed this advice. Usually, you don't, because the network rigid body component is kind of buggy. Sometimes it breaks stuff. So, after having several bad experiences with it, I've figured that I probably don't need it. Because it doesn't break my game, but when I turn it on, it breaks the game. So, obviously the problem is with the component, it's not with me. So we're going to change this to kinematic because we don't want to simulate gravity. And yeah, I think we just start like this. So we have the ball. Okay, we have the ball. So let's just click on play. Let's just click on play. And then we're gonna start the host. 1, 2, 3. Okay, it's going. Yeah, it's sort of. Is it? I don't think that is within 135 degrees. Where should we? I don't remember where does it start? Well, you need to change it to kinematic. Eh? Ay. I might have the code wrong. I mean, it sort of is going in 45-degree angles. Let me just change the launch counter to 0 so we don't have any leeway as soon as the game starts. Yeah. Okay, I think the code works. Okay, I'm not delusioning. Okay, I'm not delulu. Okay, now we have the things working. Let's change this to 3 again. So now as I click on play, you will see that this spawns properly. Now we already tested this out, so I don't think there's any reason for me to test this out. So now we also need to make sure that it collides properly, right? I also need to make sure that it collides properly. So what we're going to do first, again, is to add like the walls, which is just going to be empty objects that has colliders attached to it. That we are going to move the X and Y size of the collider so that it's big as it covers the whole map. And then as it probably move here. Yeah, okay. Okay, actually I don't think I want this to be empty. Let's just make box. Let's just make 2D sprites on this. Okay, let's just make the 2D sprites on this. It's 5. Let's add the collider to this. And then you know, just increase the size of this on the X. Just scale this on the X. Okay, 25 should be enough. Let's add an empty, which would put the walls inside as a hierarchy. Let's move this. Okay. Let's make sure I put this to 0, 0, 0. The same. Okay, -5 for this. Okay, and then we move this to the left. So 1, 5, 10, 15 maybe. Move this to 0. Move this to a -10. -8, 9. Okay, then we move this to 9. So now we have a perfect box. Okay, all of this has box collider. So the ball should also have a collider on it. Okay, it should also have a collider on it. Let's just add the box collider on. No. Let's just add the sphere collider on this. Oh, sorry, not sphere collider. Circle collider. Shit. Okay, so I add the circle collider on this, on the ball. So now I should also add the on collision enter thing to here. Okay, on collision enter 2D. And here I just want to reflect the ball. How do I reflect the ball? So I first need to find the collision dot contacts, get contact. Technically speaking, the first one should be contacts. And I select the contact. We assign this contact here, the contact point. Contact.normal. Okay, so we have a normal, then this means we can reflect it. We reflect the rigid body's velocity, the linear velocity of the rigid body, to the contact's normal. And then I assign this to new velocity. And then I assign my rigid body's linear velocity to this new velocity. Okay, so yes, I think this should in theory work. I think. So for testing's sake, I'm just going to change the launch countdown to 0 again so that it's easier for me to see what's going on immediately. Start. Oh, it phased through. Why did it phase through? That is not supposed to happen. Eh? Why did it phase through? Wait, I'm confused. Oh no, this is not in the correct direction. Okay, I'm confused why it phased through. Give me a moment. Let me think about this for a second. Yes. Let me think about this for a second. Why does it phase through the wall? Cliff, why does it phase through the wall? No, because it reflects on where I contact it. Okay, let's see if this event has been triggered. Okay, you can still attach the debugger to a multiplayer game. Okay, it's incredible actually. Let's play. Let's see if this works. So the collision is not even registered. Oh no. I think it might have something to do with this. Let's change this to continuous circle collider. I mean, it's not colliding with the walls. The wall should have the colliders on. The walls should all have the colliders on. The ball has a collider. Synchronized transform. Okay, I think we need the network rigid body here. Use rigid body for motion. I think this should work. I don't know. It's very confusing using rigid body for these kind of things, but for multiplayer. But okay, now it works. But the problem is that it falls because there's gravity. There's gravity somehow. I don't know, man. It's very confusing. Okay, now it works. Okay, now it doesn't work anymore. What the hell? Is it because I use kinematic? It might be because I'm using kinematic here. Use full kinematic context on rigid body. It doesn't make sense though. Kinematic should still collide. I don't know, maybe the network makes it difficult. Yes, I'm stupid. Okay, I think you just use kinematics context in the rigid body. In the collider. No, the rigid body. Yes. Technically, this should work without the network transform. Network rigid body. Yes, correct. So it works without the network rigid body. So let's remove this. Don't want this in my thing. But this is still not working though. Is the angle supposed to be in? Is the angle supposed to be in Euler angle or radians? In degrees or radians? Ay. Unity methods of cos. Where are you? Corner angle is math f of pi. In radians. Okay, so this should be in radians. So all you do is do math f dot dec to rad. Now it's probably better to try to calculate 135 dec to rad first, but it doesn't matter because I only launched this once in a while. Okay, this should work in theory. Okay, let us check. Okay, it phases through the player somehow. Oh, because the player doesn't have a collider yet. Okay, so in order to do it, you need to go to the ball on the rigid body, tick on use full kinematic context. Okay, so now I also need to add the colliders to my player. So let's just add the box collider to my player. And in theory, this should work. In theory, okay, I say in theory because I'm not very so sure about it myself anymore. But I go to host, and I should be able to catch the ball. I can catch the ball. No, you only need the collider. So you'll notice that by default, when you do things in a networked manner, there's no collision. Okay, there's no collision because it's not kind of like usually in cases you don't want collision to happen for different players in the season. Okay, different players in the season. So there should be a way to turn this on, but I don't remember how. Let me take a look. Let's trigger composite. You know why? You know why? I believe you just need to add a static rigid body to all the walls, and this should in theory make the player collide with the walls. It's not a problem with networking. Okay, it is a problem with networking. Is it a problem with networking? Okay, it's probably a problem with networking. Let me try to find how I can solve this. There should be server authoritative physics. There should be server authoritative physics. Let me go to the player and add rigid body. Let's make it kinematic, use full kinematic context as well. Let's go play. I'm putting on a thinking cap here. I don't know if this works or not. It still doesn't. Oh no. Might actually need to put a network rigid body on the player. Let me think, right? I think sort of the reason why it doesn't work. No, it should work. I mean, I think the reason why it doesn't work is because I'm not using rigid body as the... Oh my god, I just realized I typoed the player spawn manager. Whatever. It's not like I use it anyways. It's because I'm not using rigid body to move the player. So let's try to use rigid body to move the player instead. body, we get the component here. Object body dot linear velocity y equals move speed. Then equals to this. Let's put this in an else if instead. So this only checks for the input once. And it doesn't zero out. Okay. I think I would have to make this dynamic and then change the thing to 0. Dynamic, simulated, change gravity scale to 0. Okay, auto update kinematic status and use rigid body for movement. In theory, this should allow me to have collision. I hate working with multiplayer code. Yes, okay, now I have collision. Okay, now I spin. Okay, I spin, but that's good. That's a good sign that physics is working. So now I just need to go back here and then freeze the rotation. And also freeze the position X. Okay, and in theory, this should make it possible for me to move up and down, get hit by the ball, and I shouldn't do anything. And I collide with the wall as well. Okay, good. I think we solved it. We solved the problem. So now the clients can both collide with the wall, collide with the ball. The ball shoots in a direction towards client 0, and everything syncs properly. So technically speaking now, if I give this ball some kind of okay, let's freeze the rotation for the ball as well because I don't want the ball to rotate. If I give this ball a launch countdown of 3, let's press play. Okay, I press play. Oops. And I go on host, I go on client. The ball goes here. I hit the ball. This goes down. Okay. Looks good, looks good. I can play Pong with myself on 2 multiplayer clients. Okay, so I think this would be okay progress for today. Any questions, any problems that you've encountered? Yes? No, no, it's not that low. Now you're slowly moving down. I think because the once it gets hit, once it gets hit, the kinetic energy gets transferred again. I don't really know. Yeah, so you do need to change the code for rigid body for the physics to work. Okay, so I think today is good. This should be all that I can cover today. We are running out of time as well. So a sneak peek into what we should be covering next week. What we should be covering next week is we will try to cover syncing of variables through the network. So you know, in a Pong game, obviously we want some sort of way to score and record the score of each player into this game. So we'll try to do the syncing of variables. We'll work with the game logic, which gives you score. And potentially in the week after, we work on a lobby system with Unity Gaming Service. This is why we connect it to Unity Cloud. It makes it easier to integrate these kind of things. So if we don't have any questions anymore, I think I'll end this recording here. I'll try to send the recording up by tomorrow. There should be nothing I need to edit, so I can just drag and drop it in. Then I will also try to. I think I will also try to get things working. I'll push the repository up for anyone that wants to follow through next week, and you're not here today and you don't want to watch the video. I will push the repository up. You can also check the code that I wrote. So yeah, I think that should be all for today. If there's no questions, I will end the recording here.